we are gonna do another question, which is two forces two forces of 30 Newton and 40 Newton are inclined inclined at each other at an angle of 60 degrees. So find the resultant find the resultant what will be the resultant what will be the resultant resultant if the forces are inclined at right angles. So at right angles to each other to each other. Let's forget about the grammar at this point, because I think there's some grammar mistakes in this question and because of the way I write it. But let's look at the question. So there are two forces, one of 30 Newton and one of 40 Newton. So let's just say we have vector A and vector B for simplicity's sake. So according to the question, we have that the magnitude of vector A, let's say magnitude of vector A is going to be the magnitude of the first vector. Let's see what it is. It's 30 newtons. And let's say vector B is the second vector and its magnitude is going to be 40 newtons. And let's go back to the question. Are inclined at each other at an angle of 60 degrees. So let's say they are inclined at an angle of 60 degrees. So find the resultant. So we need to find the resultant in this case. So what will be the resultant, and what will be the resultant if the forces are inclined at right angle to each other? Also, another question that we have is, if theta equals to 90 degrees, what would be the resultant? So this case and this case. So everything else is going to be remain the same. So now we need to solve this. In order to solve this question, we will have to do two cases. So for our first case, we're going to find it in the first way. In the second case, we're going to find it in this way. So let's do this. So for theta equals 60 degrees, we know that the formula of the resultant is going to be square root a square plus b square plus 2ab cos theta, right? So we just need to add the values and we will get the answer, right? So let's add the values. We know the value of A is 30 newtons, so I'm just going to write 30 for now. B is 40 newtons, I'm just going to write 40 for now. 2 times 30 times 40 cos theta. So we have this. So now also the angle theta in this case is going to be 60 degrees, right? Since we are doing this for 60 degrees. So for theta equals 60 degrees. And you can do this by mental mathing it, but I'm going to do it by a calculator. I'm just going to input these values. So square root of 30 squared plus 40 squared plus 2 times 30 times 40 times cos 60 degrees is gonna give me it's gonna give me with a fraction that it's gonna be 10 square root 37. It's just what I got, and which is approximately equal to 61. So let's say it's 61 newtons. So this is gonna be the magnitude for the first case. But if you remember the previous or some other video, I must have told you that to define a vector, you not only need the magnitude, but you also need the direction. So to find the direction, we're gonna find it by using the direction formula to find the direction. If you do not remember it, it's tan phi must be equal to sine theta by cos theta. I'm going to measure the angle with vector A, so A will be over there and B will be over here. So that's the formula. Now we just need to keep all the terms that we need, right? So, and I think that's a pretty simple task. So we know value of each of these terms, and let's do them. So we have tan phi must equal, B in this case is 40, theta is 60, A is 30, B is 40, and cos theta is 60 degrees. So I'm going to use the calculator to find phi. So I'm going to do this directly. If you want to do this, you will have to use the tan inverse function on all of these to get phi. So I think that you can do that. I'm assuming that you can successfully do that. If you can't, learn it. Best of luck. I I give you all my support, and I believe you can do this. So you can go and learn that if you need to. So I did the math in a calculator, and I found that the angle is approximately 35 degrees. So I'm just approximating these. No need to find the exact terms since we are just trying to learn how to do this. So let's write the conclusion for this one, because why not? So the conclusion for this one is the resultant has a magnitude of 61 Newton and makes an angle of 35 degrees approximately with force of 30 newtons when forces of 30 newtons and 40 newtons are inclined to each other at an angle of 60 degrees. So I think this would be a formal way of writing it. So now we got it when it is 60 degrees. So now let's try for 90 degrees. So for theta to be 90 degrees, I think the math will be much more quicker. We know the formula of the resultant is square root of a square plus b square plus 2ab cos theta. In this case, everything is going to be the same except theta, and theta is going to be 90 in this case. So we have square root a is 30, so 30 square, plus b is 40, so 40 square, plus 2 times 30 times 40 cos 90 degrees. And yeah, let me tell you something very quickly. I'm not writing newtons in all of these terms because I will just write it in the end. If you really want to be very serious about your math, you can write newtons in any of these cases. Like even when doing the angle approximation, you can write 40 newtons over here, you can write 30 newtons over here, and 40 newtons over here. But the fun fact is that in this case, the newtons will just cancel out, so you don't need to write the unit. Since tan phi is going to give you, since tan is a trigonometric function, it's going to give you a number. That's why this is going to turn out to be a number. So this piece right over here is always going to be a number, right? This piece is always going to be a number, and this piece will always give you the unit, because suppose here, as you can see here, there will be Newton square, Newton square, Newton square, and when it comes off the square root, it's just gonna give you Newton, right? Also in this case, let's say above here there is a Newton, here is going to be Newton, and here's going to be Newton, but the Newton's going to cancel each other out. That's why it's going to give a number. So I think that you should know that, but you might have glossed over that. That's why I'm trying to tell you this. So cos 90 is 0 degrees. Sorry, so cos 90 is 0. So you can use your calculator, or you can use your mind. I'm going to use the calculator to make it much more easier, and the answer turns out to be 50. So I'm going to add the unit over here, and let's find the angle. So to find the angle, we're going to use tan phi formula. So tan phi, I'm making the angle with vector A, which means B will be over here, and tan is sine by cos. We have this, so let's add the values. B is going to be 40, sine 90, since theta is 90 in this case. A is going to be 30, B is going to be 40, and cos is 90. So degrees. So even if I don't write degrees, I'm trying to tell degrees. If I'm doing this in radian, I would tell you that this is in radian if I remember. Sometimes mistakes can occur, so forgive me for that, but I will try to do my best. I'm not really sure how this even works, but I did it with a calculator, and I found out the answer of phi. So this is tan phi. I found out that phi must equal, so I'm gonna approximate this as well. It's gonna approximately equal 53 degrees. So let's conclude this as well. So to conclude this, I'm actually going to use this, so I'm not going to write it again because this is very long, and I should not have taken the I shouldn't have made the decision of writing this, since this is very long, right? So the resultant has a magnitude of not 61, it has a magnitude of 50, and it made an angle of 53 degrees. With a force of 30 newtons when are inclined at an angle of 90 degrees. So as you can see, even when changing the angle, like we only change the angle by 30 degrees, but the value of the resultant completely changed. So this is a neat fact. I think you should have already known this, but since we did a question like that, I'm telling you. So yeah, this is gonna be it for today's video. On the next video, we are gonna check out another question. So till then, bye bye.